We're done with the random forest part. So what we will be doing now is the boosted trees, right? So a variation, the conceptual part, as you all know, is already covered in your IDS course, right? For those who have directly bought this course off the shelf, if you would have started, you would feel that there is a lack of functional aspects in this courseware. Reason being that we are always giving reference of something being covered in a course, right? So what you can do is, if you don't want to get into coding, in that case you can just procure the data science using our module only. Or if you already have the subscription of the IDS course or the certification course in complete R or the certification course in complete Python, you can use references from there to understand how the functional aspects of data science are being used over here, right? So that would be quite helpful. Nothing specific, but what we want to say is that a visual analytics course is more like a supplement. It is not a replacement for food. So if you're taking something like an protein supplement or any supplement, right, it is just to enhance and add more value, but you cannot replace it with the core things, right? So in our courseware, you cannot replace basic programming, right? So this will enhance for those who are not able to do programming. This will obviously be helpful, but for those who can do code as well as this, it makes a lot of sense, right? Okay, so in boosting we have two algorithms. One is the extreme, which is the XGBoost, and one is the adaptive, that is Adaboost, right? These are two complex algorithms. So I'm just going to quickly show you. I'm just keeping the default parameters over here. This is minimum number of trees which is specified over here, 50. Max depth, right? The learning rate, you can change that. What is the learning rate? The rate at which you are learning from the data, right? How the algorithm, how fast, how quickly it is learning, right? So when we keep the learning rate slow, that means the algorithm is taking more time to learn from the data. You can change these parameters, right, depending upon your options. You have an objective over here, that is classification. You have a linear option also. I'm keeping binary logistic because it is a dichotomous variable. Okay, fine. Iterations 50, threads 2, that means parallel processing. Okay, and I say and execute. So this will need the package XGBoost. It's one of the very powerful algorithms. If you would have to do it in base R or base Python, you would have to do a lot of processing. Here it is automatic. Say yes. You see this code being generated over here for the same. See the training error. So in the first run, the training error was 0.08, and as you come to the 50th, before that also the training error is 0, right? In the final iteration, training error is 0. These are the variables which have been used. There's no statistical significance in all of these algorithms, but they outstrip the traditional statistical models. Let's go to evaluate, and you can select your objective of finding the precision of the model, so or whatever you prefer. I'm just using the ROC because that is one of the core elements we teach in our programs, so I'm keeping that. I'm not running it on the training, or let's run it on the training as well, right? And I do it on the class base. Okay, and we say execute. Stay close over here. You see the area under the curve is 1. That means 100%. It's great, right? That's how the Adaboost and XGBoost algorithms are. Now if I look at the sensitivity, that's also is very good, right? Now you can score this model. You can specify what you want to report, the identifiers. Now I'm not going to redo this, because if I do, then what happens, it will create a file wherein I have to name this file and go and show over there, right? But you know the process. That is how you finally get your predictions. To make the predictions, you have to use score. To evaluate the model, you use any of these parameters. To finally write it to a file for the prediction, you'll have to use score. Okay, and you can do it on validation set, testing data set, full data set, whichever you prefer. Okay, So coming back over here, now I'm going to use the adaptive option, that is Adaboost. Again, it will ask us to install this package also. Okay, so this is the Adaboost package. I'll say yes one time. Okay, so almost variables which are used. Okay, and let's look at the ROC curve. So I'm just going to execute this. So it is near 1, it is almost 0.96. Okay, so the extreme boosting, that is the XGBoost, gave you a better area under the curve, right? For the training one, if you see, it might show you 1. You're getting my point? So under training, the area under the curve is very good. When it comes to the testing validation data set, there might be a slight change, right? So when you overfit, which is a normal thing in all these models, in final new incoming data, the parameters of test, basically the precision, sensitivity, all of these will drop a little bit. Okay, so here we have covered the boosted trees, extreme boosting and adaptive boosting.